Yep, thank you everybody for joining in. Today we have PR number 255 25991. Can everybody see my screen all right?
Yeah.
Okay, cool. So let's get started into this PR, which doesn't have any description, and but it says like it fixes this issue. And this issue is about a transaction where the fee and the amount of get transaction call doesn't match with the with the actual fee that it should be, right? And the reason it happens that the PR claim that the issue claims is basically we don't have a correct way of denominating which inputs of the transactions are ours and which inputs are others, and that has some implications on the way fees are calculated for this field and this fields. And it could be argued like the way this interaction happens internally between these two fields, the way this value is calculated is the like very good way of doing it. I'm not very sure. It's very complex and convoluted how these two values gets updated and calculated. And so what looked as Junior's solution is basically create another RPC and provide some extra data to the wallet so this calculation doesn't get messed up in some ways. So with that introduction, let's get started. Quick question: how many people like looked into the code and looked into the PR? Just the basic description of it doesn't mean like you have to go deeper. Just quick yes no.
Yeah, Shreyan and I just briefly went through it. Not the code, just the GitHub issue and
Cool,
some related issues.
cool, awesome.
Me too. Quick look. I didn't dig deep.
Yeah, awesome.
Oh yeah, side question.
Yeah,
Anytime during this call, could we go through that example transaction which you showed in the issue?
which one? Sorry.
Uh, you showed a transaction right now in the issue, like fixes some.
Oh, right. Yeah, yeah. This one. This one.
Yeah,
Yeah.
yeah, yeah. Like,
Right. Yeah.
could you explain what's
So
actually happening?
that's in testnet, no? So I couldn't dig in,
Yeah.
but yeah, I guess
So
you have screenshot.
let's look into this transaction, and it's possible in mempool space, and but it's into testnet, so you have to like change the like the network to testnet and basically paste this transaction hash, which is over here. And this guy will not work for some reason. I don't know. And if we just look into mempool.space, we see this transaction over here, right? So this is the overall transaction flow. So the transaction has two inputs and two outputs. One of them is very small, one of them is very big, right? And it's probably a kind of pay join transaction. And so what this issue is saying is take a look at the transaction, and the input is like this: a 1.02 of BTC, which is mine, and a 1.1 of BTC, which is not mine, like some transaction that is coming from somewhere else, some input that is coming from somewhere else, and the output is zero point 0.1 to not mine and 2.1 to mine. Right. So what should my wallet say when I say like the details of the transaction when I say get transaction on this hash? So the wallet should say like I gave away 1.02 BTC. I spent that input of 1.02. I got 2.101. So I'm 0.99 BTC reaching. Right. So I definitely gained more in this transaction. But what the wallet says is like the amount is minus 0.1 something, and this is the huge fee. And if you check, the fee is quite low. So the fee of the transaction where is like 500 and like 518 sats only. um oh what, it's a $34 transaction, like 5,000 sats, and the fee rate is 2,000 sats per byte. What? Okay. um
It's testnet, right?
oh right, it's testnet. But why then this fee component over here is showing so small? Oh no, it's not small. Oh, actually, like the amount is so big. So okay, right, makes sense. So yeah, because it's testnet, and so this was like around 2.1 BTC transaction. So that's why like the proportion is this big. But the fee is like clearly wrong. That's the point. Like the fee is around something like 0.005 sats for 0.005 BTC, and get transaction says 1.9, right? And that's the problem. And then later on another guy says like from another wallet, like transaction, like weirder from the other side, it's like the wallet where 1.1 is mine and 0.104 is mine. So these twos are mine and these are not mine. For them the transaction should be a loss of this much, but it's showing some loss of -2, and the fee is also clearly wrong, some this value. The question is the why the hell this is happening. And so yeah, does that answer the question? And then we'll go deeper into why the hell this is happening.
Yeah, then yeah, now I understand better. Amounts are usually shown negative. Like, does that normally happen?
For send kind of transactions, like transactions where you are sending out or
Hmm.
spending your input and giving it to somebody, the amount will be showing as negative. So that like puts us very neatly to this part of the code where this amount is getting calculated. So um, we will go in a bit, we'll go through the structure of this wallet code. Like it's kind of interesting to see what are the different things that are used. But here's the RPC of get transaction, and
Hmm.
basically this is the RPC help. So if you do Bitcoin CLI help get transaction, it says get details of information about a wallet and transaction ID, and among the first two is the amount in BTC and the fee that is in BTC. So we should be able to find that inside this RPC. And inside wallet, in the source wallet folder, there is this folder called RPC, which defines all the RPC functions, wallet related RPC functions, right? There are other RPC functions elsewhere. So so get transaction is a wallet related RPC call. You'll find that definition inside here transaction.cpp inside wallet RPC folder. And like all other RPC call, they follow the same structure. It starts with these help manuals, and then it goes and implements the code. And here you can see like the push value amount is being pushed in that output JSON. And this value from amount is calculated from n net and n fee. And n net is calculated from n credit minus n debit. And this is where
Hmm.
the interaction with our outputs versus other outputs happens. So given a so the logic between n credit and n debit is given a transaction. If a transaction spends an output that we know about, like is mine, the output
Hmm.
that is mine, then that amount of that output will be get into n debit. And if there is an output in that transaction which is also mine, so we put another output inside the transaction which has a script pub key that is monitored by the wallet will go like, okay, that's my script pub key, so it's also mine in the output. Then it will put that value into n credit, and n net is the difference between n credit and n debit. And that's what is meant by amount in this field, right?
Hmm.
So
Makes
it's a bit it's a bit of a mess. So what is going wrong here in this example where the amount is being wrong is like the wallet is getting confused about what is credit and what is debit.
sense.
Does that make sense?
Yeah, it does.
Okay, because it very clear vaguely makes sense in my head still. So the problem seems like we need to somehow fix that problem of identifying n credit and n debit. And somehow that problem is related with identifying which of the which of the outputs are ours and which are not. And okay, so now can anybody and hit on the point, like how did this PR approach to solve that problem? If that problem is identifying our amount, our output versus their output, how is the PR trying to solve it?
I think it's some kind of new function to is foreign output to detect if the output is ours or theirs.
Right. Anyone else?
So there's this new RPC function. I think you can submit raw transactions.
Yes.
So you have to manually add those, right?
Right. Yep. So yep, that's basically covers it. And the way he did it is like he added another RPC call called um, send raw transaction to wallet. Uh, Let me see. Is it in spent or CPP? Yeah, submit raw transaction to wallet. So this one basically added this entire RPC code, and this new code is basically what is asking is like give us a vector of identifiers, and with this transaction where the user is specifying this inputs of this transaction is ours. Now this is very confusing. It's called like foreign outputs, but it's actually marking inputs, and this is I found like in general overall confusing around the code base. Like it's mixed all the time, like which is outputs and which is inputs. So it but theoretically they are same thing, because an input is a pointer to an output, so there are only outputs. So but different contexts it means different things. So here foreign outputs means basically inputs that our wallet doesn't own, and it's the RPC is saying like specify in the call which are the foreign outputs, then the fee calculation will be correct. And the way it worked is probably somewhere in the issue or somewhere in the PR. He said like, okay, so this guy tried to do it, and there was a comment by Lokjuni where he said like you have to pass in the flag like this. Yeah, submit raw transaction to wallet, that the raw transaction hex going in, raw transaction hex, and a foreign output like list. And this foreign output list is specifying 0, 1, 2, 3, 4. And I'm not sure why it's specifying 0, 1, 2, 3, 4. From the help of this document, list of outputs sent by other wallets, example for CoinJoin transaction, index of an output to mark as foreign. So I'm not fully sure whether this particular value will work for this transaction, because it doesn't seem to me like the transaction has like 5 outputs, like 0, 1, 2, 3, 4, 4 outputs in that way. So but yeah, it's asking for a new field where the outputs are being specified by the user, and then only it will. So this guy said like, so do I need to run submit raw transaction for every coin join? Yes. So then only it will try to provide the right fees. Has anybody like dared to even try it out? Yeah, it's any question at this point, and any other parallel discussion?
I'm very confused.
Yeah, we all are. So here's the thing that I found interesting in this PR is like Sticky V's made a comment is like, so the gist of this comment is the wallet always knows what's is mine, right? So there is an is mine function inside the wallet, and the wallet
Okay.
always knows what is mine. So why do we need to like externally specify for a transaction that which are foreign? Whatever is not is mine is foreign, right? So
Yeah.
Yeah, right. So that makes sense. And his question was, why don't just do that? And there was no answer for it. And it seems like that should be the right way to do it, because it makes sense as a wallet engineer. Is like your wallet is like a script copy manager tooling system where you are tracking different addresses and script copies. So you should always know which is yours and which is not yours, right?
Hmm.
And probably there is a easier way of like solving this problem in that approach, but so far nobody has tried it out. And yeah, so any comments on that? What do you guys think?
Yeah, I don't know about this. Uh, I don't know the wallet code enough to know this is my thing. But I had a quest. Like my confusion was more related with, like, I don't understand how these RPCs connect with each other. Like there is this get transaction, and we saw in the issue that it's showing the wrong output,
Hmm.
and then there is some new RPC, and then there was something else in the comments which showed foreign flag, and they were passing 0, 1, 2, 3. Like how do they all relate together? How does that
Right. So,
finally affect get transaction RPC?
right. So I think all what your question is. Uh, what your question is like, so what happens like if we use this function call, what changes? And so
Yeah.
that gets the finally the get transaction thing fixed. I think what changes is like this foreign outputs for this w transaction map. So um, there is so after this I think instead of like talking about this PR week, what we can do is like go through a code base tour around this wallet transactions and what are the different things inside this structures that comes into play. And what is happening in this last part of this RPC is this guy is like there is this foreign outputs that is getting mapped from the input, right? The user is getting this input which is getting stored in this foreign outputs. And the wallet transaction also, this is the wallet transaction structure, and a wallet transaction structure is called C wallet transaction structure. We'll look into details in a bit later. It has a field called M foreign outputs, which is a vector of bulls, right? And which is
Hmm.
basically flags for each output index, or actually each input index, to mark them as ours or theirs. And so imagine like if there is a transaction of four inputs, 0, 1, 2, 3, 4, 0, 1, 2, 3,
Okay.
and among them 0 and 1 are ours, 2 and 3 are theirs. So this M
Okay.
for an output will be 0, 0, 1, 1.
Okay.
So it's a vector of bull where each flag is identifying whether the output is ours or not. And what it's doing is like simply copy pasting the foreign output value that we got from the input users into this guy, right? And then just recording that transaction. What it does is at the end, when this get transaction is called, where did our get transaction is called, where this confusion was happening inside n credit and n debit, these guys read this M foreign output field from the wallet transaction and update it accordingly, which then gets fixed and the N net get fixed. Does that make sense? This is how they're like connecting the flow of the changes.
Wait, filter is N for an output. Wait,
No, this filter is something else. This filter is called um, yeah,
where is the
wallet
foreign
filter.
output here?
This is
Oh,
called the
WTA.
is mine filter. And this is mine filter is a type definition called is mine type, and which is an enum and which is a flag, basically a bit flag that determines different is mine conditions. And it can say like whether this output is mine watch only, is mine spendable, is mine used, is mine all, is a mix of watch only and spendable, all used is a all and used. So this is a flag that gets transmitted that um,
Oh.
cool. Uh, is one thing.
So we
Yeah.
already have the filter, like what you
Yes.
talked about.
Yeah. So it's getting set here. So it's getting set for is mine spendable, and if the watch only flag is set for that wallet, then is mine watch only is also set, and this end credit depends on this filter.
Ah, foreign
Now I'm
output is
also not like very clear about how this filter is actually like doing the internal gears and getting this cash transaction out, but basically depending on this filter, end credit will change, and
okay.
this and debit is also dependent on the filter. So this is where end credit and debit is like related with is mine concept.
Ah, yeah, a little clearer.
Yeah. Any other in general questions before, like I really want to move on to like the uncontextual part of like going through the code base. So we probably will not talk about this PR much, and for the rest of our time just walk through different part of the structure. So anybody have any PR related questions, because we can also go through the question set covered over here, but these are mostly like C++ related questions rather than this PR related question. And so until and unless if anybody is specifically interested on specific part of this question, we can skip it for this week.
So I have a question.
Yes,
Uh, so the fee is actually the output minus input, right?
let me go back to the code. Yes, the fee is getting calculated by this function, and which is like saying cached transaction is for me. If it's true, if it's the transaction is from me, then get value output minus debit. If it's not from me, then fee is zero. So it's basically saying like the fee will only be there for transaction which are from me. If I didn't send that transaction, or this transaction doesn't um, or this basically logic says like whether the fee is paid by me, not like the fee of the transaction. Does that make sense?
Also, this get transactions, the fee shown in get transactions only shows the fee paid by me.
Yes, and the help is also saying like this is negative and only available for the sent category of transactions.
Okay,
And
okay.
sent category of transactions are transactions which are spending. Send and spend is analogous in this code base, and it's basically saying like all the for all transactions which spends from my inputs, from my known inputs, then we will only have a fee. That means like if the fee is not there, somebody paid the fee but it's not me.
Okay, okay, understood.
But that's a good question. Yeah,
So
it's
I
it's
was thinking,
hmm,
like, the mempool is showing the correct fee, but then why can't Bitcoin CLI show the correct fee? Like,
exactly
if we,
because it's trying to do this magic over here, and this is adding a lot of complexity. This part is adding a lot of complexity to this entire thing, and this PR actually got really complex on like trying to solve it. And yeah, any other in general question can be related to ownership, is mine calculation. Let me just cover through the question set once and see if we can find something interesting. Um, so here's the question that kind of hints onto that point. Like the wallet is, there is already an wallet is mine. So why do we need wallet is for an output? Because is for an output is something that is not is mine, right? So we should be able to like cover it from negative of his minds, right? And in
so
the RC, yeah, go ahead.
My question is like maybe I don't know CoinJoin well enough, but could it be that CoinJoin is implemented so that due to privacy and stuff, even Ismail doesn't work properly, and that's why the developer tried this long way around.
Huh. Um, I don't see why that would be the case, because if the coin join is created by the like the coin join output that got included in the coin join transaction is created from Bitcoin Core wallet. So Bitcoin Core wallet already has the data to identify whether that script pub keys is mine or not, right? So that's only true for general coin join transactions where the wallet doesn't know about the script pub keys of the input. But even if it's a coin join or regular transaction, if it's created by the wallet or the Bitcoin Core wallet was part of that transaction, I don't see why the wallet will not know that data even if it's CoinJoin, because CoinJoin protocol doesn't do anything to stop that.
Oh, okay.
So that's a good question to ponder, and probably is a potential candidate for a parallel PR that can do that approach instead of like trying to specify externally by the user what is not ours. We already know what is ours. Why not just use that information and try to do it internally? So that's a good question. And this is a question that says like there is a change, whether this change is a behavior or just refactoring. The RC conversation goes into a depth about this, and this is not this PR related, but specifically, if we can look at this commit, but no, this commit is gone and probably got like um, overridden. So there was a change that could have a behavior change, and but eventually it's not, and it had to do with um, um, the checking of the amount. There was a checking of the amount going on that got removed, and the question was whether that checking is done elsewhere. If it's not, then that's a behavior change. If it already covered that check elsewhere, then that's not. And luckily, they found that it's already got covered elsewhere, so it's not a behavior change. Um, in So this is another C++ question on the on the standardness of the code change. So the developer note indicates that we always prefer post increment. We always prefer pre-increment instead of post-increment. And if I can find the developer note, uh, it's included here. Is miscellaneous plus I is preferred over I plus plus, and there are some C plus plus nuances going on over there that makes these standardized rules, and this PR kind of like like invalidates that rule. Um, in this code base, yep. So this loop, if you see, this goes I minus minus, and so the question was, does that make difference, or is it worth going against the standardness? There was like no clear answer in the IRC call also for this, so that's another good C++ question to ponder. This is another C++ question: is the foreign outputs, M foreign outputs, is this vector of tool that we just seen? And if we go to the definition again, this is the M foreign output types that is part of this wallet transaction, and which is a vector of bull. And there are some C++ nuances going on about vector of bulls, and whether that makes sense or some other kind of data structure would make sense. Again, open question. And this is this one is like amazing. And what is the purpose for this loop in C serialization for I equals to 3 values set to, and what does it mean? And this is one weird loop, and this does something with the iterators, and this happens like when this happens in the serialization of the C transaction. So this is a C transaction, wallet transaction. That's like the core structure of any wallet. The wallet transaction, the wallet is basically a store of lot of C wallet transactions, And C wallet transactions are transaction data attached with metadatas that are storing our wallet related transaction, which contains a field called M foreign outputs, which is this map, right? We saw this M foreign output, which is this vector of bull, which is a map of all the inputs which are not ours. And happens in the serialization of that vector. And it uses some really convoluted logic over here, which includes some modulars with 8 and some string operations and some string XORing. So the question is, what does it do? How is it working? And how yeah, how it is doing the changes? Just the serialization part. I don't know. Like, to me, it feels like this is overly complex to write a bull to a serialization format. I might be missing something, but I'm pretty sure there are easier way to do this. I don't know. Anybody has any other opinions, comments, or pondered about this point?
No, it's complicated. We could dry run through it if we have time.
We could, but I think we can do something more useful than this. Yeah, but if anybody has like a dry run and can do a step through of this process, it's a very interesting thing. I'm pretty sure it's a very interesting thing, and it's a good exercise. It's a good C++ exercise of strings, and check how this is getting done. But if can anyone make a small step-by-step write-up, maybe like with I equals to 3 or I equals to 5, taking a value and see what this operation looks like, could be a good useful add up for the docs that we'll have for this year.
I by 8 is confusing. Like, if it's 3, 3, 2, 1. Like 3 by 8 is still 0, 2 by 8 is still 0, 1 by 8 is still 0, 0 by 8 is still 0.
Yeah, so it's
No,
basically
override by 8.
overriding a single. This is an index of a string, so this is saying like get the character of of the string at that position and overwrite it with this value. And this value is like modulo of 8. So I equals to 3, this will be 3. I equals to 5, this will be 5. And then it's like left shift of 1 with that value and override that string at that index with that value. So what is happening is like for I equals to 1 to 7, this will be 0. So for I equals to 1 to 7, the same value will get overwritten. And then for I equals to 7 to 8, it will be 1. Then the first byte get overwritten. And so on and so forth. But I am not fully sure if it, I don't even understand what it's trying to do.
Yeah, me too.
Yeah.
There was a PR comment now asking what does this do, and there was some Stack Overflow answer. Was it
Can
some
you
other
like
for loop?
find that? That will be interesting to look at. Let's see.
Just Sipa's one-liner.
Yeah, that's a one-liner answer to that.
Okay, I haven't. I missed it. Let's see. It's by SIPA.
I
Yeah.
don't know. I think they were discussing something about the peer review club itself. For my peer review club, it would be helpful if I knew what this does.
In the peer review club discussion. Okay. SIPA. Let's find for SIPA. They had some discussion over undefined behavior.
Oh,
Foreign
I don't think
output.
Sipa sent it. I meant Sipa replied on Stack Overflow. I do not remember where I saw it.
Okay. Anybody can gist it out? Like, what was it about? I can't find anything
I
other
think
than
it's here in the chat. It looks like it packs the values into a sequence of bits iterates over each char per byte in the string 8 times for each bit.
Could you share
Can
the
anyone
link?
post the link in the? Okay, right. This is why the conversation is happening, and then okay. So I think Sticky V is saying like Sticky V has a review comment regarding this, and somebody ran through some point where like this value is this, but I can't find like
Oh, I found the link. Uh, I sent it on Jitsi.
yeah. Let me copy that. Help explaining some C++ code I haven't seen before. Okay, okay, and it's creating a string where each character value is composed of bits representing 8 booleans from n foreign value packed together. It's creating a string where each character value is composed of bits representing 8 booleans from m foreign output values packed together. Oh my god. And
So is a string 8 bits? I mean one byte
a
or
string
eight.
should be 1 byte,
Ah, yeah. So I think
and it's
it is.
representing bits of 8 booleans from m foreign value. So this was a structure of vector of bools. So it's taking the 8 values together and compressing into 1 byte. Oh, it's compressing into 1 byte of a string.
Yeah,
Okay.
I 8 though.
8 is 1 byte,
Because
right?
yeah, 8 is 1 byte. So
Uh,
string of one index. Where was that code? Where are you looking at it? Um, I'm looking at the code here. No, let's trace it back. Okay, let's look. So, huh. So S of a particular index is a byte, and for each byte is repeatedly putting in the value of I modulo 8. Okay, it makes sense. It made sense to me as far as it could. So something like that is happening over here. Yep, I don't have any further comment on that part. So that's something. And there is this last question that wasn't discussed on the RC also. Um, are foreign outputs persisted on disk? If no, why it's not necessary? If yes, which code is responsible for doing it? Does anybody have like explored at least the first part of this question? Are the foreign outputs persisted in disk? Because me neither.
I mean, I don't know about this, but again, back to the is mine question. Like, if somebody wants to take it up, they can.
No, it's okay. Go ahead.
Uh, yeah, yeah. Like, okay, we're doing a coin join. There's Alice, there's Bob, there's Carol.
Right,
I'm Alice,
right,
and I've done a coin join with Bob and Carol, and we have sent uh, our coins to 3 different addresses.
right,
So, being Alice, uh, I know which address belongs to me,
right,
and I should potentially know like the address of the person to whom I send it to, the
right,
UTXO.
right.
But
Or I
all of
should potentially know the addresses that are not mine. That's what you're hinting towards?
not the input, not like uh,
No,
yeah,
both
like
both inside of inputs and outputs. Like
so.
in
I'm Alice, so I know my address. I do not know Bob's and
Bob's
Carol's,
address, right? Yes, yeah,
and I can identify that Bob's and Carol's are not mine.
right, exactly, true,
But suppose I send it to you,
right,
and Bob and Carol also sent it to some other people, but like we made
hmm.
a coin join, and I know that I've sent it to you.
Right.
Like when I made the transaction, I know I sent it to you, and
Right.
but now it's in your UTXO.
Right.
So uh, my wallet would not be able to know that.
So my wallet should identify. So your wallet should identify that UTXO as not is mine, and my wallet, like my core wallet that generated that address that you paid, should identify that UTXO as is mine.
Yeah,
You're hinting it right, but what's the question?
yeah, but so okay, so I sent it to you, and Bob and Carol also sent it to two other people. So
Right.
all those other, like all the three receivers, all of them is mine would be false from my perspective.
For your from your perspective, yes, yes, true.
Yes. So I do not know who I sent it to.
No, your wallet doesn't know who is sent it to. The only thing the wallet knows, you might know that it's me or somebody else, but the
Yeah.
wallet only knows that that's a foreign output that we are sending to. So the wallet will consider that thing as a debit. That does that make sense?
The sending.
It's a sending. Yeah.
Okay. Yeah, I was just trying to tell that, like, yeah, exactly the same. The wallet wouldn't be able to understand which output, like after a year or something, if I check it,
Yeah.
the wallet wouldn't be able to know whether the UTXO I sent, wait, like the wallet wouldn't be able to know whether who the receiver was, whether I really
Right.
sent it to that receiver or not.
Right. Yeah. Yeah. You're right. Is that
Yeah,
like
yeah, yeah,
really a
yeah, yeah, yeah,
confusing?
yeah, yeah. Yeah, just.
I'm like confused about your confusion, but that's okay. Yeah, it's worth also like trying to spend some time around these functions
Hmm.
and to check like how these values are getting calculated, and this is a very crucial part of a wallet engineering. It's like all about tracking your wallet's output inputs and outputs, and script pub keys, calculating balance, fees, and stuffs properly. So
Wow.
core has a way of doing it. Different wallet does differently. There is no one single way of doing it. But walking through and like looking into this structure of code is probably a good exercise if you are like interested into wallet engineering and those kind of stuff. So for last 10 minutes, we probably wanna do a basic walkthrough around the wallet code, which will give you a basic idea about what part of the codes are where, and will um, will help in that exploration. Basically, we'll see like where these transactions functions are defined and where they're coming from. Shall we move ahead to that, or anybody has any further question regarding the PR?
We can move ahead.
So basically, the wallet folder inside RPC contains all the wallet related things. It has different folder. One folder is called test that includes all the wallet related test, and RPC for all the wallet related RPC function definition. But this is where the remaining part of the C codes is where the engine is happening. And the biggest part of that is wallet.h. And this wallet.h contains probably the outline will be easier to follow. Can you guys see this outline over here? It's readable.
Yeah, I can read it.
Right. So this wallet.h contains this structure called C wallet. And the C wallet is the final wallet interface that does everything. So it has a bunch of like APIs that you can query things, put things into it, and do a lot of stuff. So everything that you wanna do with a wallet is defined here. So this is C wallet, and this is inside this wallet.h, this folder of wallet.h. And that's the transaction structure of C wallet. And the wallet.cpp is basically, again, if we look into the outline, it's basically a list of functions. All the functions that are defined in the wallet.h C wallet structure, these are like the implementations of it. So all the functions are defined over here. So C wallet and C wallet.h, wallet.h and wallet.cpp. That's where like the juice of the wallet is. And then the next important structure is transaction.h, which defines this big structure, wallet transaction. And this wallet transaction basically is a definition of a transaction that is related to the wallet. The entire job of C wallet is to store this C wallet transactions. And we can see that inside here, there is a map called, um, map wallet, this guy. So map wallet is basically an unordered map of transaction hash and a C wallet transaction and transaction ID hash. So this is the entire wallet data, if you may, and it's basically storing C wallet transaction. So this is the main structure of the wallet that the wallet deals with, and it's defined in the wallet transaction. Transaction.h and transaction.cpp is like, interestingly, very empty. It is basically two, three utility functions which could have, like in theory, defined in the transaction.h also, but somehow they decided not to, and this is like a very empty function. But this is like, these three are the juices of the wallet. And then there are like other auxiliary tool, wallet utility, wallet database. This is the database, like the file storage interface of the wallet. And these are some tools and these are some utilities. Then we have like two different kind of things, two different kind of files called spend.h and receive.h. Where is receive.h? Let's close RPC. Um, receive.cpp, receive.h, receive.cpp, which are basically like bunch of functions. There are no structure inside receive.h. So receive is like, and receive is like, you can say like these functions are heavily dependent on is mine flags, and it depends on whether things are is mine or not. And receive is all the functions that you want to call on is mine, where output is ours. So does that make what that this basically defines what a receive is called in code? A receive of a transaction is a transaction which has an output which our wallet knows, like, or output which for which is mine is true. And that's all the functions that you want to call for such transaction where we are receiving stuffs. And spend.h is just the opposite of it, where a
Wait,
transaction, yeah, go ahead, sorry.
what is the last point? Output for which is mine.
So
Wait, can you repeat that?
so a transaction has list of inputs and list of outputs.
Yeah.
We can apply the
Yeah.
concept of is mine for both inputs and outputs, right?
Well, like if the output is mine.
Yes. And for in case of input, if the input is mine. If the input is mine, we consider that as a spend. Does that make sense?
An output is mine, it's changed.
It's a receive. It cannot be a change also. It can be like somebody paying me. That in that case also the output is mine.
Okay. Yeah, makes sense.
So all the cases where the output is mine, it's a kind of receive. And all the cases where the output is, or the input is mine, it's a spend. And these two files, basically spend.h basically defines this function, spend.cpp declares this function, spend.cpp defines them. Same for receive.h and receive.cpp. So these are the two components. And this is like the things where like these things are defined. So cash transaction get amounts, right? So if you remember in the call of the transaction RPC, where the fees and stuffs are getting calculated, transaction, get transaction, it was in get transaction, where is get transaction, here get transaction, and push this cash transaction credit and cash transaction debit. So if we go to the definition of them, this is defined inside receive. So cash transaction credit is receive. So it's a form of receive. So if a transaction has an input that is so if a transaction that is has an output that is ours, it's a receive, and cash transaction credit will give us that amount that we are receiving through this transaction. And the same way, um, inside this transaction.cpp cash transaction debit, this is defined inside, oh, this is also defined in receive. So um, I don't know. This makes like this is like the transaction which is like debited from us, so input is ours. Theoretically, this should be inside spend, but I mean they just put it in that way, and spend is other parts of the transactions, which other parts of functions that are available of spending an output. Okay, so this includes all the select coins and coin selections and all those kind of stuff. And receive includes all the amount detections and credit debit detections and those kind of stuff, right? So these are the two files that you should take a look at. Then the major another part that is like a big chunk of wallet engineering is this is a big file, and this is called the script pubkey manager.h. And the script pubkey manager is basically a class which it's a virtual class that is implemented by a bunch of other structures called legacy script pubkey manager, descriptor script pubkey manager, and this defines a class that is a pubkey manager. So if you're a wallet engineer and if you wrote a wallet at some point, you might have like wrote a variation of this engine, a pubkey management system. And underneath every Bitcoin wallet is some form or other of a scrub key management system. So this is very interesting, and it's worth taking a deep dive into this part of the code base. Though like this is very opinionated in the way like how this is done, and it makes sense for core, for if you are writing your own wallet might not, but a good resource to gather inspiration. Script pubkey management or CPP is the same thing, huge file with all the implementation of the functions that are declared in that thing. And salvage, these are also small auxiliary things that doesn't include much. Loading is about loading the wallet data from the file system to the memory. And then there are like bunch of other auxiliary things: coin selection, coin control, some wallet related context, and some database implementation, some dumping systems like and fee bumping systems, fee calculation system. And this is initialization, like what gets called when you like start a wallet or like create a wallet, right? So this is in overall the wallet code base architecture. That's all I had for the tour. And like anybody has any specific questions?
So, are other wallets able to solve this coin join problem?
Yeah, this is not a problem in BDK, I know for sure. And this is not generally a problem for other wallets. Bitcoin Core wallet is like it does a lot of things good, does a lot of things bad. So this is part of the thing that it does kind of poorly, and identifying the amount and fee. Also, like the way this amount on fee is like calculated is not also optimal in my opinion. Could be done better and simpler actually. Like, it doesn't have to be this complex. This is not a general problem for wallet, because as Stratosphere was also saying, like as a wallet you already know what is yours and what is not yours. So you should be able to like should not have a problem of fees, and the fee should not be transaction fee should not be dependent on where stuffs that are yours and not yours. Transaction fee is a constant thing for a transaction, right? Mempool.space like clearly very easily shows what the fees of the transaction, because you don't need to depend on that information to calculate the fee. But here the fee is meant by something else. It's like it's the fee that we paid, and that extra context that we paid makes the thing more complex.
Okay.
Thanks for the tour. First time seeing all the components in the wallet. Like I didn't know there were so many stuff.
Yeah. Yeah. There are few things in the wallet stores and quite interesting to it. We are just at the end of the session, so feel free to shoot any questions. We'll hang around for 2 3 more minutes. If not, we'll call it a day. Any other conceptual question also goes. Doesn't have to be related to wallet or PR or anything in general. Okay, guys. Then we'll go for a wrap. And thanks for joining in. This has been a deep and tough one, both at the PR level, but it also like allowed us to like look into some part of the code that we haven't touched before in our review club. So that was interesting. Later on, I'll try to like also add few more wallet related PR so we can like play around with different structures. The good thing about wallet is like it's very easy to play around rather than other than like P2P and other stuffs. And you can like go and debug into it, write functional tests, and like just play around with RPC and see how other internal functions are working. And so yeah, if you have any other suggestions for PR, we are always looking for PR suggestions, so feel free to post us in the group. And yep, and we will be back on another PR next week same time. Thank you everybody for joining in. See you next time. Bye bye.
Thank you.